Right now, I wanted to show you about load balancers. I'll go to load balancing section. So why do we need load balancers? See, suppose till yesterday, if I showed creation of instance, I was just creating a one instance, right? I was creating some instance in Nginx or any default HTML. I was giving some tag or something, default HTML content. But it was in a single instance. And suppose we have created a basic application and launched in this instance only. Uh, but after some days, we try to get some traffic as the time increased and as the days passed. Uh, After a certain time, my instance is not able to handle the requests. When it reaches a peak thing, right? So it breaches its CPU and and memory. It goes down. So the CPU will not be able to withstand the load that is getting because it's a single instance. Because see, you have made a request. I'm making a request. Some other users also making a request. Inside, it needs some handle. It needs some time to handle the request and send you response, right? But before that, I am making one more. So another thread is being created. Likewise, so many threads will be created, and it will just shut down. It goes down because it will not be able to handle the load anymore. So in that cases, we have a downtime. So basically, when we are designing architecture and defining infrastructure for enterprise applications, right? We have to build in such a way that it is highly available and fault tolerant. Fault tolerant is nothing but if there is failure also within the infrastructure, it should be able to withstand and it should be always highly available to the users. So you should design in such a way that any failover should be it should be able to handle. That is what we call as highly reliable. Reliable. If you see some features of cloud, right, we come across some terms such as highly available, high reliability, and all. But all these features comes with a cost. Uh, Initially, I created a single instance, so that was sufficient to show you some basic kind of web application with some basic HTML content. But if I want to have multiple instances, right, to ensure it's highly available, if one instance goes down, it is able to handle another instance is able to take that place. So this also comes with a cost. Imagine there is a single load balance, single instance, and it's been hit by many users and it went down. So next time I'll design something with the load balancer. I'll create a load balancer and on the back end I'll place the instances. So I'm not directly hitting the instance. I'm hitting the load balancer. Now suppose also if we are hitting to Amazon.com and or any of the uh, regularly used sites, right? Those are you are directly hitting the load balancer, not the instance. The load balancer in turn is taking your request and routing to the particular instance. It follows a algorithm called round robin algorithm. Suppose I had hit now. The request there are four load instances behind the load balancer. Since I had hit first, it will go to my the load balancer will take my request and send it to the first instance. And suppose anyone among you had hit the load balancer next time, it will route the request to the second server. Similarly, for the third user, it will goes to the third instance. So that there is enough time. By that time, the request that was sent to the second instance, right, is able to handle and send the response to the respective user. Similarly for the fourth. Here, so there we have some time to handle. Uh, so let's imagine we have two servers. It's pretty much it's able to handle the load since we have high configurations instances also, the high GB RAM and good amount of CPU. Then two instances are sufficient. So basically, we will be knowing that how much we need. Uh, so they have a track about the users, right? They know about the product and how much traffic they are getting. So they have some certain figure what we need to design. But in case we could try also, initially we'll have some dev and testing environment, right? They do some load testing and all to test the load. So if it is not able to withstand some 5,000 users, they might increase the configuration of the instance and also try. But yeah, there should be load balancer in place. So if they want to increase instances also, they could increase 4, 5, or 10 based on the traffic they are getting. So that is what a load balancer is. In load balancer, we have three types. One is classic load balancer, and another one is application load balancer. Another one is network load balancer. Oh, okay. This is something I'm able to see. Gateway load balancer. I've never seen this. This is the first time I'm seeing this gateway load balancer. I don't know when they have released. So I know about this application. We were using classic, also we were using network. We didn't use till now. They say this is our very high performance, but for our applications also this requirement we didn't get. Classic load balancer is a like very basic load balancer. It'll just send the request to the respective instances. You are hitting the load balancer, and they take your request and send it to the particular instance. Next, this is the mostly used application load balancer. It's a kind of intelligent load balancer. It can do also host-based routing and also path-based routing. Host-based routing in the sense you see some domains, right? Uh, Something to google.com or something as blog.google.com also. So if you're hitting a google.com, that website will be redirected to a particular instance. And again, if you're hitting a blog.google.com, right, that content is deployed in a certain instance again. So that will be redirected to the another instance. That is how we could place rules here. Similarly, path-based routing. If you see, I have a same host, something as mm, some company name, some technologies.com something, and they have some slash careers page, right? Slash contact us. If they're hitting slash contact us, then I can route that request something slash careers. If they're hitting that endpoint, right, slash careers, then I can move them to, I can create a rule and route to the particular instance here also. So we are basically breaking the microservices. So if it is Amazon.com, right? Not all the applications are handled on particular service. So there are many services that are broken. We are just distributing all these services. We are just uh, mm, creating all this the big architecture is a very simple small components, like payment is a one service, uh, a sign up is a one service, and again add to cart, that is a one kind of service, registration is a one service. So all these are a particular services. Each service is a kind of application. So your application is consists of all these components. So every service is a small component here. So that is how it is able to handle. So it's not like that entire Amazon.com is running on only one instance, the payment service on one thing, and the other rest of the services on rest of the other services. It will be managed by different teams, right? So only I should be ensuring if it is a payment thing, the payment should be able to work. If it is something working on transactions and OTPs. They need to ensure that is highly available. That service is highly available all the time. So each services gets communicated. That is how that VPC peering also happens. I told you VPC peering, right? It's this service is in a particular VPC, the another service is in a particular VPC. Let's create a load balancer now. And before that, I'll create one instance also so that I can attach to my EC2 instance here. Quickly create. So app VPC public submit. Enable. So use user data. Slash. I have launched this in one E. So just I'm making sure that I launch another one. One C. Just we'll give some names here for identification. When we have so many of servers, right, we'll not know what kind of what server is running and what application is running on these instances. So I have instance 1 and instance 2. So instance 1, it shows it's almost running, but I will need to confirm statistics. So if we'll have this system statistic and instance statistic, that is good. Then we'll put it's running. Okay, welcome to instance 1. That is ready. Okay, by the time I'll my load balancer, I'll create that Applebee. So it is an internet facing load balancer. It listens on port 80. Uh, so I select my app VPC. Here I need public subnet because this is what the instances I'll place here. Public subnet, and that is done. The next step, configure security settings. So I'll have this in VPC security group only because there is port 80 group allowed, or we can create some load balancer security group allowing port 80 also. So it is asking for a target group to create app target group. App target group on the instance. So this is protocol 80. This will be default. The protocol HTTP path slash means by default they has given us to check on the where www slash HTML Linux index.html. That is the path that is going to check by default. I have advanced health check settings. So I have some threshold here, maybe after attach. What does this mean is for every 30 seconds it will make a request, and if it is healthy for 5 times, it is getting the for 5 times for every 30 seconds it will make a request. The next 30 seconds one more request. So in 60 seconds there are 2 requests made. Similarly, if five it needs to get 5 health requests, it needs to have, I think, 2.5 minutes. 60 seconds, 30 seconds once, right? So once it gets 5 health checks passed, then only it makes instances healthy. The other way is it will makes for every 30 seconds it will make a request. It is gets unhealthy. It will wait, at least wait for twice. If it is getting twice unhealthy, that is means for 1 minute it is getting unhealthy. It will make the instance unhealthy, so that we won't be able to do connect to the instance. So but for every 30 seconds is a bit time rate, at least to make the instance healthy, it is taking 30 seconds. So I'll make it as 5 seconds. So every for 5 seconds it will check. So for 25 seconds is, if it will be able to make the 5 requests, right? For every 5 seconds one request. So it can make the instance healthy within very short time. I can discuss later also about this one. This should be smaller than this. What it says. So you are able to see my instances here, right? I can register my instance here to the target group. So let me add one instance initially. Okay, load balancer was created. So I have my load balancer here, and also I have my target group here. So it doesn't have any registered instances. So let me register. I'll register my instance 1 here. So now that all those configurations what you showed, right? It'll come under here. It'll until it gets 5 health requests as a successful request, it will not make it as ready. So if we are having like for 30 seconds, right, we need to have 2.5 minutes to get this instance ready. This is what I was talking about this. So we saw anyways this instance was running here, it just was able to give the response. After this is successfully available, this should become healthy. Then it means that it would be able to serve from the load balancer. Okay, let me also do the second instance as well. Or I'll wait for some time till the system. So we are placing the instances behind the load balancer so that next time I won't hit directly this instance. I'll hit load balancer, it will go to the thing. Because if I'm hitting a particular instance and if I give to this to so many people, right, it can go down if, within a very short time. Okay, so the instance is healthy now. So this means I can hit my load balancer. So this is my load balancer. My load balancer has a DNS name. So I'll hit my load balancer only. I'll not hit my server. So it will go to the my server and get the response. Similarly, I'm hitting my load balancer. It is giving my request, taking my request and giving the response from the instance. Now let me also add the other instance to the target group. Second instance at target group. Register targets. So I have this first instance was in 1E, right? I have one more running as 1C. So this also becomes healthy. When this becomes healthy, we should be able to see a response from both of the instances. So this is what I was saying initially. When we have this domain right single instance, we'll configure this domain name. If we are configuring the domain name to this IP, suppose if you have stopped the server, uh, so it will not be able to find the respective instance. So again, I need to configure, go to server and check what is the new IP, and then with that name IP, new IP, I need to configure the domain name. But here I just can configure the domain name to my load balancer only. So this load balancer remains the same. Oh, I think it's already got registered also. So it's already healthy. I'm able to see I'm hitting the load balancer. So in turn, it's sending the request to the instance one and instance two, and whatever the content that is there in the instance one and instance two, it is giving to the users. Suppose if one server goes down, also there is no issue now. Like we had with a single instance. So similarly, we'll have 4 to 5 instances. It depends upon the application and how critical it is and uh, how much traffic it is about to get. Based on that, we'll We will get the details, but we should be able to configure this. That's it. But you'll not get different content, right? Just for a demonstration purpose, I showed you instance 1 and instance 2. But you'll be hitting the load balancer, suppose Amazon.com, you'll be getting the same content, right? But here I wanted to show you it is uh, handled by both of the servers. The load is handled by both of the servers placed behind the load balancer. So, but we won't be able to know, right, from which server we are getting the response. So here, that is the reason we had different content on different server. But usually, anything that is behind the load balancer will have the same content. I mean, same application like Amazon. So this is my load balancer. I created load balancer. Everything was default. I didn't do anything extra. Just I changed that interval only. I changed from 30 seconds to 30. Just for your sake, I'm just telling you. I didn't do. There is no any complexity also, right? So initially, whenever the load balancer is about to make a request, right, it'll do health check actually. Instance, the load balancer will do a health check. Only if the health check passes, then only it mark it as healthy and sends the traffic. If it is not, it is unhealthy, right? It will not send the traffic. So this happens constantly. The configuration, what we had said, right? The interval, health success, and failure threshold, and unhealthy threshold, and healthy threshold. So initially there was 30 seconds. This is what I modified, so that if I have wanted my, so that is why how we got that instance to very quick. I mean, so speaking in terms of the interval I said, I think it will take 25 seconds because once one request per 5 seconds, it needs five consecutive health checks. Then it marks a success. So this is about load balancer, auto scaling. I think it will take time. So we have something CloudWatch alarms and important. I'm just talking in terms of what would be necessary for you.